Over 100 years ago, somebody in the newspaper wrote, "A picture is worth 1,000 words." So me and Christopher Nolan, especially for you, prepared over 3 million of resilience examples just in 2 minutes of this clip.
The enemy tanks have stopped.
Why?
Why waste precious tanks when they can pick us off from the air like fish in a barrel?
There are 400,000 men on this beach.
He's coming back round. He's coming back round!
Where are we going? Dunkirk.
Not going back.
There's no hiding from this sun. We have a job to do.
If we go there, we'll die.
You can practically see it from here.
What?
Home.
Developers from the British Expeditionary Force, you are here in Dunkirk and you are surrounded by the enemy. There is only one way to survive, the sea evacuation to your home country. But we don't have enough warships and the bay is too shallow. It's time for Operation Dynamo. It's time to use over 850 private boats of Dunkirk. They are distributed and available via Boats API. Please use this API in a responsible and resilient way. Good luck. My name is Tomasz Skowron and today I will talk not only how to survive on the beach full of enemy fighters and bombers, but also how to survive in a world of resilience, when each event can happen badly for us. Why do we need to think about resilience? Because almost everything is a distributed system. We live in times when it is enough to implement client-server architecture to just have a distributed system. Why do we need to think about resilience? Because even small failure can be beginning of big, long chain of failures, cascading ones. Why do we need to think about resilience in our systems? Because as developers, we often forget about error handlings. And I'm not thinking about exceptions logging or throwing them into faces of your users. I think about real case error handling when we can provide some value in case of failure. When some part of our system doesn't work, it doesn't need that all our system should respond with error. Probably it could be answer or provide some smaller, simpler feature. I am Java developer, so my examples are prepared in Java. But as you can see, there are a lot more resilience libraries, and each of them implement some part of resilience components which implements resilience patterns. If you heard about resilience, probably you heard about circuit breaker, and then even you aren't Java developer, you must heard about Hystrix. But Hystrix is dead. It's no longer in active development. It is in maintenance mode, and for 1 or more years, it is only maintenance. Only security patches will be applied, if they will. So my examples are written in Java, and not in Hystrix, but in Hystrix successor named Resilience4j. Resilience4j is a lightweight library in contrast to Hystrix, which has 3 dependencies. Resilience4j has only 1 dependency. It is waiver, a functional library. But you don't need to use it because it isn't part of open public API of Resilience4j. Even Resilience4j promotes functional interfaces from Java, like, of course, function, but also supplier, callable, runnable, or future. We can't say that it is functional code because it could be difficult to say about functional way in context of retries or timeouts. But Resilience4j use these interfaces, functional ones, and also promotes decorator pattern. Okay, enough theory. Let's go to first, probably the simplest one, pattern. Do you have this feeling that you stay at the end of long queue, very long one, and ask, why does it happen only for me? Probably yes. Time limiter is a pattern which allow you to provide timeouts. But isn't a timeout some kind of exception? Of course, it is an effect of error. But let's imagine what happened in world without timeouts. You can wait, and there is no answer. So it is better to have timeouts. You can think about time limiter as if it were a timeouts factor, because with Resilience4j, you need only future supplier. That means promise provider, and you can wrap it with time limiter and add and configure timeout. Let's see it in practice. The first example is very simple because it is a happy path. That means we create here. What we need to use Resilience4j components is a configuration. Of course, don't use default one because even you know the default values, the rest of your team doesn't know. So it is good to provide custom values like here. And now you can construct any component like time limiter. Time limiter is a specific one because it only works with, as I said before, future supplier, but with other components, you can decorate not only future, but not only supplier, but also functions, callable, runnable, and others. So what you need now is to use time limiter created just before, add your API executions, method executions, whatever, and wrap it, decorate with this time limiter. So in case of our test, we allow max for 100 milliseconds for executions. In our first test, we sleep only 42, so of course there is a success. What is try? Try is a monad from waiver. It is like an optional, but in case of error, it isn't empty. It contains the reason of failure. So instead, writing code like this. I prefer to use try. Yes, because now in this try I can verify is it empty or no, or what kind of exception it contains. In the second test, you see example when our execution time is longer, and it is the reason why the result is empty and there is a timeout. Let's go to the next pattern. It is a rate limiter. It is also about time, but this time has different meaning. That means we don't limit the duration of executions, but the number of executions in some time period, some time window. So you can think about rate limiter as if it were a throttling factor, because you can simply apply throttling not only for your server, but also for your clients or clients of your external dependencies. In this picture, you can see a green image, blue lines on the front, first plan, and they show there is no limit of executions, but the green lines in the background shows that there is a limit 1,000 per each second, maximum of executions. Let's see example. So, as before, to use resilience component from resilience4j, we need configuration. Our period is 2 seconds time window. We limit executions not for 1,000, because this is just a test, but for 1. And that is almost all. So again, what we need is to use component, use our method, like here it just logs some information, and decorate it. And now we can execute it twice, and there is no surprise because we limit to 1 executions per time window. The first call is successful, and the second is failure, is not permitted. The second example is more interesting because configuration is almost the same, but the second call, there are also 2 calls, but the second call is also successful. Why? Because there is a change in our configuration. We allow we added a timeout. It is like a delay. That means first call is successful because 1 call is permitted for each period, but the second call should be not permitted, but because of our time duration, it is delayed 2 seconds to the next window. And because there is no more calls, this call is permitted. It will be visible in runtime. You can see the first call is here, and the second call, even they were started 1 by 1, is delayed here 2 seconds. So because sometimes it is better to time out something than not permit. Retry is also a very popular and simple pattern. But sometimes we often forget that rate limiter or the timeout or retry are even patterns. What it do? Of course, it repeats the failures. So if your call is successful, you even don't know about retry. What is interesting in resilience4j that you can make your resilience component smarter. That means you can add conditions. Let's see the example. What we have in our configuration of test. There is a server, it is mocked. There is our API, there are just two methods inside, and our retry. We choose interval function, this condition and rule retry on exceptions. And we have two configurations for our mock server. If a URL ends with 500, like in REST or HTTP statuses, it will return server error, but if it ends with 400, it will return bad request 400 status. So in first test, there is no surprise, because we try to receive this bad baud. We do it once, but there are 3 calls to our API. And there, the second test here is an example of this smarter approach. That means we try to receive our baud number 400, but because it isn't server failure, it is our fault, but request 400, there are no retries to the server. Even retry was used. And there is example of how to find is use waiver, because try monad is from the waiver library. You can simply see here that we can, using method recover, provide some simple fallback. So even there is no valid response from the server, we will finish with some empty fallback. I will tell about fallback later. In Resilience for J, you can configure interval functions. Default one is constant time, what sometimes for simple cases makes sense, but probably you should switch to some other functions. You can choose from provided functions like random one or interval expansional backoff, and probably it is the best choice, because as you can see on the picture, if something doesn't work at the beginning and it doesn't work after the moment, probably it doesn't make sense to check it after the same time. Yes, let's give our server or our service some more time, check again, and if it doesn't work again, just wait longer and then check. It doesn't make sense to run like in the loop, yes, and check. And of course, it is very simple pattern, but people often forget about this interval function, that it shouldn't be a constant value, like 1 second, and the number of repeats. Probably each 3 is enough, because if something doesn't work, it won't work at the moment. And Bulkhead is my favorite pattern. It looks similar to rate limiter, because it also limits the number of executions, but not per period, not per time window, but per moment. So it means it limits concurrent executions, so we can use it to protect resources pool. What is Bulkhead in real world? Everybody heard about Docker, but you should know that bulkheads can be used in ships constructions and in docks constructions. There is example of ship without bulkheads, and here you can see what bulkhead is in the real world. It's some kind of internal walls to partially protection of all docks or all dock or ship. And let's go to the example. Please imagine this situation. 1 boat, 20 people, and only 4 paddles this summer. And now 4 people without imagination, the same story, but in code. What we have? We have only 4 paddles and 20 threads to create. And there is a first case, the most naive one. That means we will try to use these 4 paddles That means create 20 threads, start them at the same moment, and let's see what happens. So you can see that even there are only 4 paddles available, we created and started 20 threads, what doesn't make sense. And what is more interesting, what doesn't also make sense, the number of available paddles, which we log here, is sometimes even below the 0. It should be between 0 and 4, but here it is below 0. So let's add synchronize to our paddle now method. You can see it here. Because we need to protect our resources, our paddles. And here you can see that still we created 20 threads, start all of them, and the number of available paddles is at the beginning 4, because we start with 4, but then later it is always 3. Why? Because we can use only one part of our resources at the same time. Only one paddle is in use at the same time. That means 3 of them are never used. And in this scenario also some threads try to slip, what is surprising. And now try to use this, do the same, but with Bulkhead component. There are 2 bulk isolation strategies in Bulkheads, like in Hystrix. That means thread pool Bulkhead and semaphore-based Bulkhead. Let's start thread pool 1. And here you can hear we have a lot of executions, but there are only 4 different threads. What is great, because it doesn't make sense to start more. Also, the number of available paddles is between 0 and 4, what is also good, because it should never be below 0. But you can see there is a lot of executions. Why? Because thread pool implementations use queue, so we can minimize its size to 1. It is the smallest possible value. And let's see what happens. Results are very similar, but first, there are 5 executions, because we have only 4 paddles and queue has size 1. And the rest is okay, because only 4 different threads were permitted to start and access our paddles. But let's switch to a semaphore-based implementation. And it is even better, because here under the hood is semaphore used. There is no queue. So even we create and start 20 threads, only 4 of them, because of our bulkhead, because only 4 of them are permitted to execute and access our resources. Okay, fallback. I said a few words before, but let's say again. First, a movie example. Sometimes it is better to achieve empty boats that can swim than nothing, because it can help us. Yes, maybe some more realistic case. Let's imagine you are a movie platform like HBO Go, and one of your feature doesn't work. Then nothing works. It was a very good example. It was a very bad example of resilience. So maybe let's try again. Let's imagine you are Netflix, also a movie platform, and your recommendation system doesn't work. Then, instead of disable this feature, you can provide a fallback. For example, for recommendation service, if it doesn't work, you can provide a static list from other service of the most popular movies. And a lot of people won't see any difference between the most popular movies and recommendations. And it is a kind of fallback. I will show you also an example extension to Resilience4j. What is Feign? If you know Android and retrofit, Feign works similar. That means you can generate HTTP client from simple interface. So you provide the interface, and Feign build or retrofit build HTTP client from this interface. And instead of decorating each of method of this client, you can decorate all API client. Let's see how it works. Normally, you need to create Feign or retrofit client. You need to provide interface, like here, and you can configure the decoders and encoders. For JSON, we use here JSON. And what is interface? It is plain old Java interface with some annotations. And that it's all. Instead, it is a declarative way to create HTTP clients. And it is how Feign works. But with Resilience4j, we can add resilience components to this, like rate limiter, fallback, or circuit breaker. And thanks to that, we don't need to decorate all methods later. So, how could looks example of fallback? Very similar, very simple one. We configure our server to return always errors. We try to get an existing boat, and you can see that our server was achieved. So that there should be some exception or error response, but because of our fallback, we receive valid response, and there is a boat with the name, and it is default one. How it works? Let's see here. We created fallback that for each server error, that means HTTP status higher than 500. Don't return error, just provide fallback. What is fallback? In our case, instead of null or error response, we provide empty list in case for method get boats. Instead of null here for get one boat, we provide some default dummy boat. In this case, it is the live raft. Because sometimes it is better to receive the most popular movies instead of server error, just because recommendation doesn't work. There are also other extensions for Resilience4j, because it promotes decorator pattern and functional interface from Java standard library. It is simple to connect this library with other ones. So if you don't prefer functions or builders or decorators, and you prefer aspects-oriented programming, reflections, and you use Spring, you can use Spring annotations, configurations, or if you use reactive program, if you program React in a reactive way, you can use Resilience4j transformers or operators, and there is also support for other libraries or metrics. I will back to the metrics in the moment. So, the circuit breaker is probably the most popular pattern. It is the most complex. Because also it is stateful. What circuit breaker do? You can think about it as if it were a errors cache, because it is some kind of opposite to retry. In case of errors, we count them, and if our circuit breaker decides to disable this service, the server isn't more executed code. Maybe example will be more clear, but again, you can see this picture. You can saw this picture before. It is a logo of Resilience4j, but it is also a diagram of circuit breaker. Just remember 3 words. There are 3 states in each circuit breaker: close, open, and half open, because circuit breaker is a finite state machine. Okay. In this test, we have our server, we have our boat's API, you know it, and we have a list of events. Each Resilience4j component emits metrics and also events. And with events, you can do almost everything. For example, metrics, but also you can verify behavior in tests, like here. So our server always responds with error. It doesn't work. Here is our configuration of circuit breaker. I will go back to it. And we collect all events emitted by circuit breaker. And here we decorate our API with circuit breaker. Then in test there are 10 calls to our API, some short break, and again 4 calls. What is interesting, at the end, even there were 14 calls, only 6 of them achieved our server and boats get API boats met endpoint. Okay, what happened? First, there are, as we remember, there are 10 calls. But after 4 of them, because of our configuration, ring buffer size in closed state, our circuit breaker at this moment decide to check how many errors were before. If there were more errors than threshold, it's time for transit to other state. At the beginning, circuit breaker is in closed state. That means it doesn't work. It is disabled, and it allows to service calls. But if there are more errors than successes, like in our cases, and it is enough items in history, circuit breaker can decide to switch the state. And next calls, 6 of them, are not permitted. And it is the reason why at the end only small numbers of calls achieved the server. Now our server is protected by circuit breaker, and it has time. It can be restarted, there can be some auto-scaling group works. We don't need to attack to make a DDoS for our service or external service. And after some time, we configured it to 100 millis. It is the time of our short break. After this time, our circuit breaker switched to half open state. And in this state, it is open for some small number of calls. In Hystrix there is 1 try. Here we can configure how many calls are permitted. The number is 2. And because our server still doesn't work, circuit breaker again switch to open state, and service is unavailable, and rest of calls are not permitted. Of course, 4 is a very small number just for test. Probably we should, in real world, it should be bigger. The same about time. And that is all about circuit breaker. Cache is another popular pattern. Resilience 4J doesn't implement cache, but it uses standard interface, so you can use with Resilience 4J almost any cache implementation. Here I won't show you a cache, how cache works, but how to connect more components in one executions, for example. I said before about decorator patterns. Now it will be visible how it works in case of more than one layers. This is example how to use nested decorators. It isn't too clear, so maybe switch to explicit decorators. What we have? First, we have our API. We decorate it with our retry. Then we decorate this retry with circuit breaker, and then we decorate it with cache. And we need to use a cache key. Because it is a call for get both, there is no individual key, it is just some constant value for all collection. And now we can execute it. And what will happen? The first will be used more external layer, that means cache. Next, if there is a value in the cache, it will be used. But if not, our call will achieve circuit breaker. If circuit breaker is closed, it means it is disabled. Then our retry will be achieved. And if there is a success, that is then our both API will be achieved. You can also use compose this structure, but you can also use the most the simplest way. That means this builder. That means get our boats from here, but use retry, use circuit breaker, and cache. And the order is reverse. That means first we check in cache, later in circuit breaker, then we apply retry. You can think that the way from Dunkirk to Dover, it has just 8 days, but it was difficult and full of unexpected events. You can think that resilience patterns are simpler, but it is just a beginning of your adventure in the resilience world, because first, there are more patterns, and the second, what is even more interesting, not all of them make sense on the lowest base code layer. What I showed you were the patterns which you can apply in your code. But there are more patterns which you can apply on containers, on API gateway, service mesh, or even using a cloud provider. For example, Elastic Load Balancer from AWS. What should you remember after this talk? Nothing from this list, but it is good to know that the smallest board used in the operation Dynamo has just 5 meters of length. What you should remember after this talk? First, even you can apply our patterns, don't do it. Not because you can use annotations, but because if you apply them in a wrong order, it will be even worse. For example, retry and circuit breaker don't work together, especially in wrong order. Don't decorate everything, not only because you can use some other kind of integration. but because sometimes it is better to know what doesn't work. So sometimes it is better to fast fail than fail safe. And use metrics, not only for colorful dashboard, not only because each component emits metrics, but because you need to know good values for your systems. You need to make tuning of them after you deploy them. And even my examples were related to HTTP client, this both API. Resilience patterns are more universal. You can apply them on each external service, but also on internal components. Almost everything what depends on threads, time, or disk file is unpredictable, and resilience can make sense for it. It is all for me. Thank you for attention.
A little bit technical question. So in the example with caching decorator, you've put it on top of the circuit breaker. So does this mean in resilience for J that it will cache fallback value as anything else? And should we think about it, or it will somehow magically know it's a fallback and just not cache it?
Okay, first it was the most complex example where I applied a lot of 3 or 4 components. The first one was cache, and it is good because if we have some value, we can get it from the cache. Later I was used retry. Retry shouldn't be before circuit breaker, because it can kill our circuit breaker and open them, and it doesn't make sense. Is it an answer?
Absolutely, but then circuit breaker can provide a fallback value, right?
Yes.
It still fails after retries, and then we have a cache on top of it. So the question was, is it going to caching decorator? Is it going to cache the fallback value from circuit breaker?
No, because in this example, cache was the first layer. It was decorated at the end, but it was first used, because the order is reversed.